All right. So free response will be a projectile motion, a vector addition, and an inclined plane. If y'all want, we can go through another one of those if you like. Not this one. We've already done this one in class, I think, for everybody. But we can go through this one right here, this inclined plane problem, and then we'll come back and find another, another projectile motion. Erase all this. It's going to be a tough exam. I've told y'all, I don't mean to scare you, but it is going to be a tough exam. I expect the average will be similar, but it's going to be tough, so just beware. All right, first step, draw the forces. All right, so I'm going to draw my coordinate system first. Yeah, okay. Oh, this is exam 221. All right, so draw my coordinate system first. Now I'll draw my vectors. I already have one vector drawn on here, so it's that 120 newtons. And I'll get in class. I don't know if y'all are okay with that, but skipping that step and just go ahead and finding the components of the weight vector. It just saves you that extra step. So I'm going to go ahead and do that. I think we've been doing this long enough. So this is FW cosine of what? 60, right? I take that 90 minus 30. And then this is FW sine of 60. Then there's the normal force as well. And that's it for now. The first part assumes no friction, and then later it asks for our friction. So first of all, what is the normal force? All right, remember as I'm looking at this, because there's no acceleration in the y direction, then I can just say outright that the normal force is equal to FW sine 60. So the normal force is equal to FW sine of 60. That will often be the case. I think actually for us it's always the case, but it doesn't have to be. Like if I had some other force that was pushing down on the block at some other angle, then it would make a normal force that was different. But as far as we're concerned, it will always be that. And so that's equal to 87 newtons. Second part, assume no friction. What is the acceleration of the block? The block is going to be accelerating. In fact, it's going to be accelerating in the negative x direction. That'll be my acceleration. So in order to find that acceleration, I say the sum of the forces in the x direction is equal to max. And then the sum of the forces equals 120 minus FW cosine 60. That's going to be FW cosine 60 is 100 cosine 60. That's equal to 50. Which is equal to the mass, which is 10, times AX. So that gives me an AX. Did I do something wrong? Yeah. It is being pulled upwards. Yes, that's what I did wrong. Or I didn't do anything wrong. I was expecting a negative number here, but then I didn't get a negative number. Right. So that's always a. Abby? Oh, 120 is given in the problem. It's right here. That's that force right there. Okay. So yeah, it should instead of being in that direction, it's going to be in that direction because it's being pulled up the inclined plane. I was expecting it to go down, but notice that when I do this, I get a value that's equal to positive 7 meters per second squared. So I would rethink, what I thought. So that's the second part. The third part, assume the coefficient is 0.1. Then two questions: what is the frictional force, and then what is the acceleration? So now I'm going to add this other vector here that is my kinetic friction. And that kinetic friction opposes the direction of motion. I know it's accelerating up the inclined plane. To find Fk is relatively straightforward. I just say that Fk is equal to mu k times the normal force. If mu k is 0.1, I've already found the normal force. It's 87 newtons. So that means that my frictional force is 8.7 newtons. And then finally, D, I really just redo in part B, except now the sum of the forces in the x direction includes 120 minus 50 minus 8.7. 120 right here, minus 50, minus 8.7. And then that gives me MAX is equal to 10 times AX. 10 is the mass of this block. 70 minus 8.7. 6.1. So A is equal to 6.1. That's very similar to the one that we worked this morning in class. Very similar to the one that you'll have on your free response. Though the one with your free response will be almost identical, just the numbers will be changed. So what to the one that was on last year's exam, fall 22. This one's very similar to it though. All right, we good for that? Y'all can do that now. Do you feel like you could just walk in and you could do it right away without much thought? Maybe. Yeah. If you're sort of so-so, that's okay. But by Monday, we definitely want to be there. Okay. It'll help you on the other parts too. Let's find one that is a projectile motion. Okay, yeah, so this is a good one. Notice, by the way, this number 2 is basically identical to the one that we just worked. It's asking the normal force. It has a force that's pulling it up the inclined plane. So same steps you're going to take for that. Just, for this one, your projectile motion will be really similar to this. I'm going to have an object that goes up and comes back down. By the way, this is fall 19. I think this is the first year I started doing free response. Goes up, comes back down. Remember, some key ideas about this are that the x velocity is constant throughout. It's the same throughout the entire trajectory, but the y velocity begins big, gets smaller, goes to 0, and then gets bigger in the negative direction. So we'll use this fact that Vy at the top is equal to 0 in order to find our time. So the first part, or your first step really, is to find that time. So for part A, to find the time, I say that Vy at the top is equal to V naught y plus AYT. Oh, and by the way, I want to go ahead and find my x and y components. I just like to do that up here. I'm going to need both of them, so I'll go ahead and find them. V naught x is going to be 18 cosine of 30. V naught y is 18 sine of 30. That's equal to 9. This is 18 cosine 30. That's equal to 16. Sort of write it up at the top because you need those at various times. So just do those first. Same for your force problems. Go ahead and find the x and y components. Just write them up there at the top. We sort of do that in your vector diagram anyway. All right. So Vy at the top is 0, right? That's what it does at the top. V naught y is 9 minus 10 times t top. So t top is 9 divided by 10, or 0.9 seconds. That's 0.9 right here. That's going to be 1.8 seconds right there. So to find the maximum height of the ball, still in part A, I do this y equals v naught yt plus 1/2 ayt squared. And now that I know the time, I'm just plugging that time in. Of course, I have two times, 0.9 and 1.8. But at the top of the trajectory, I use the time. At the top of the trajectory, that's the 0.9. So that's going to equal to 9 times 0.9 plus 1/2 of negative 10 times 0.9 squared. We get 4.1. That's this height. It's 4.1 meters. All right, so that is A. For B, these parts all follow. They build on one another. So if you made a mistake in the times, if you do the other parts correctly, I'll still give you full credit on those, even if you get the answer wrong. Just make sure that you show your work clearly, because if I can't see or understand your work, then I can't know to give you full credit or even half credit. So please just show it clearly. Obviously, I don't have great handwriting, so I'm not asking you to be great penmanship, but just be clear on what you're doing. So for part B, what is the horizontal range? X is equal to Vx times t. I already have Vx up there, that's 16 meters per second. And my t, I need to know to use the 1.8 seconds. So that's 16 times 1.8. That's 29 meters. For part C, I've already answered that question, right? It's 1.8 seconds. I'm just going to write that. But I showed my work up top. And now, what is the speed at 1.1 seconds? So 1.1 seconds is going to occur right about here. And that speed will have two components. It will have an x component that is 16 meters per second. That's the same as my initial velocity, right? So it doesn't change. To find the y component, I have to say Vy equals V naught y. That's 9. Let me write out the equation, actually. V naught y plus Ayt is equal to 9 minus 10 times the time, which we said was 1.1 seconds. 9 minus 11 are negative 2 meters per second. So I have one vector that's at 16, another vector that's at minus 2, and so that's going to give me my speed, which is going to be the square root of 16 squared plus 2 squared. Which is basically 16, 16.1, I'll say. Okay, so you'll do that. I can do that. I think we can do that. That was on your quiz, so I think we're pretty good on that. Yeah. You want to do the vectors thing too? If you want to, yeah, it'll be on the free response. So, if you get the vectors, then you're probably doing pretty well on the 2D. Some of those vectors are going to be in exams 1, so I'm going to open up one of those. Often that is in exam 1, so just beware. I made y'all the packet, right, that had all of those. Yeah, so use that if you're studying, if you're doing it on your tablet or you print it out. Do I not have any? I thought I had some. Vectors, a 2D vector thing. Yeah. I know there's one on 21. Let me just find a multiple choice. It's okay. Fall 22. Exam. Number what? Yeah, I think I've already done this one though. Yeah, I did it in class. All right. Let me find a multiple choice. We'll do a multiple choice. They're all the same anyway. So exam 1. Okay, fall 19, number 11. Thank you. Fall 19. That was just before COVID. Y'all were in high school, weren't you? In fall 19, most of you. Don't look. Y'all look away. Okay, so right, I said it's nice to draw the picture because it just helps you to check your answer. 6 units at 60 degrees from that plus x-axis, that's right here, and then 2 units along the negative y-axis. I'm going to draw it about the third the length. That means that my sum of those two vectors is going to look like that. So it better be in the first quadrant. Better be something less than 6 units long, but more than 2 units long. So I can actually get rid of some answers right here. It has to either be B or C. Y'all see how I did that? Just the way that I draw it. Okay. If this is 6 units long, units along the negative y-axis, then this is clearly shorter than that vector. So I can get rid of several answers, although it's free response, so yeah, never mind. So the first thing I do is find the x and y components. Ax, ay, that's 6 cosine of 60, 6 sine of 60. That's 3 and 5.2. And then the same for b. Bx is equal to 0, and by is equal to negative 2. Be careful on that sign, okay, because likely you're going to have one that's not in the first quadrant. If it helps you, you can also draw it like this, where A looks like this, B looks like this, and it'll help you just realize which quadrant each is in. This is the vector A, this is the vector B. It's important because when you add them up, you know, the Rx is going to be 3 plus 0, which is equal to 3, and then Ry is going to be 5.2 minus 2. So those are my x and y components. In order to find r, that is the magnitude of that vector, I have 3 squared plus 3.2 squared. I get 4.4, which gives me the answer for this one. But then also I want to know the angle, this angle right here. So that angle theta is the y component over the x component. The inverse tan of opposite over adjacent, 3.2 over 3, close to 45 degrees. All right, 47 degrees. Okay, I'm going to ask both of those. I'm going to ask the magnitude as one question, and then the direction for the other. Make sure that when you write the angle that you give me the proper axis. So this is from the plus x-axis. But likely your vector is going to be in the second, third, or fourth quadrant. So just beware. I'm pretty sure that it is. Be on the lookout for that. I could be wrong. I think it's in the second, third, or fourth quadrant. So you'll be measuring either below the plus x or above or below the negative x-axis. Draw a picture. It helps. Okay. Other particular questions. That's for your response. Other particular questions? By the way, that's about the right time frame. 20 minutes is about how long you want to spend. It's a long exam. All right, not long. You know, I make the videos, and I like to have them done in under 25 minutes. And this one took me, I think, about 27 or so minutes. But that's with me talking and sort of stepping through each. But, you know, I also know how to do it because I wrote the thing. And so I don't have to think about it, and y'all have to think about it. Abby? Yeah, it's good. So this is a 1D problem, so it seems relatively simple, but if I apply a 40 Newton force to a 10 kilogram mass, I should get an acceleration of 4 meters per second squared, right? F divided by m, 40 divided by 10, that's 4. But this one's only accelerating at 2 meters per second squared, so I must have another force that's acting on it, that's causing it to just slow down from what I would have normally. It's going to be the same procedure. I'll draw my picture. I'll label my forces. My horizontal force is 40 newtons. It really doesn't matter the direction that you draw it. It'll work out. If you draw it the opposite direction, the signs will cancel out. And there's another force that's in this direction. That is my kinetic frictional force. There's also the normal force, Fn, and then there's also Fw. Unfortunately, I don't have the mass. Oh, no, I do have the mass. Yeah. So I have the mass, so I can figure out the normal force. I know that because there's no other vertical forces, that the normal force is equal to the weight. And since this has a mass of 10 kilograms, I know it has a normal force and a weight of 100 newtons. Now, if I want to know mu, we've done this in class, mu is equal to the ratio of F over Fn. Our mu k is the ratio of Fk over Fn. Right, that just comes from our equation Fk equals mu k times the normal force. So I have the normal force part of that is equal to something divided by 100. Now I need to figure out what is Fk. So to determine that, I say that the sum of the forces in the x direction, which is 40 minus Fk, is equal to the mass, that's 10 kilograms, times the acceleration. Be careful that you're not putting in 10 meters per second squared, because this thing is not vertical, right? It's not vertical acceleration. In fact, the acceleration is given right here, 2 meters per second squared. Let's just check our sign too. Whenever you write acceleration, just pause for a second and think about what direction is it. But this thing is accelerating in this direction, so that is a positive acceleration. But still, every time you write acceleration, just pause and say, what's the sign of this acceleration? Can y'all do that? Every time you write A equals something, what are you going to do? Pause and just think about it for just a second and say, what is the direction? Pictures help a lot with this. It will really help you to write diagrams, draw pictures. If you're just doing your calculator or even in your head, not going to do well. So I can figure out Fk. It's just 40 minus 20, or it's 20 newtons. So I have this other force up here of 20 newtons. Then that goes back to where I was before. I can put in my 20 newtons divided by 100 newtons, so the answer is 0.2. That's a good question. And you will see one something similar to that. I don't think it's exactly like that, but it's a one-dimensional problem that has friction involved in it. I want to try this problem too, number 19, while we're here. We did one of these in class today, but let's just take a look at this one. It's similar, and we'll do 17 as well, because you'll see one of those on the exam. So here the block is stationary. That means static friction is holding up on the block. Which of the following equations is true? When you get to this problem, draw the vectors, draw all the forces that are on it, label the angles and stuff. I have my normal force. Look, I'm going to skip that step again, okay? So this is FW cosine of 60, and this is FW sine of 60. And then Fs is up and in that direction. I know it's up the inclined plane because it's opposing the direction of motion, or opposing the direction that the object would tend to move. If there were no friction, this thing would slide down the inclined plane. So the frictional force then is pulling it back up the inclined plane. All right, so let's see. How about this one? Fn minus Fs equals 0. No, because Fn is on the y-axis, Fs is on the x-axis, so they're not related at all. They're completely separate from one another. Fn equals mg. No, I could correct it and say mg sine 60, but as it's written, not correct. Fs equals Fw cosine 60. Yes. Okay, so that one's correct. We're going to get rid of that one, that one, that one, and that one. So now I'm stuck with only D. But let's just look at 4. Fw cosine 60 plus Fs equals 0. How could I make that correct? Yeah, I put a minus on one of them. The way that it's written, I'd put the minus on this one. Fs minus Fw cosine 60 equals 0. But I could put the negative on the Fs too, and that would still be mathematically correct, but it just wouldn't represent the diagram correctly. Okay? You know what I'm saying? That I can just multiply both sides by -1, and we'll make Fs to be negative. But it doesn't represent the directions of the vectors properly. But it's mathematically correct. So anyway, that's not correct either. And then can we do number 17 as well? Don't forget those kinematics equations. There's not going to be complicated kinematic stuff, but there'll be one like this. There's only one, but I want you to get everyone right. So here, we did one of these early this week on Monday. First thing you need to do is find A. A is equal to F over M. That's 12 over 4, or 3 meters per second squared. And then what is the velocity? Well, V is equal to V naught plus AT. That's the same equations that you'll need for the projectile motion, except here there's no Y or X because we're just in one dimension. And so that's going to be 0, assuming it's initially at rest, plus 3 meters per second squared times 2 seconds. So that's going to be 6 meters per second. Or I could ask you, what is the X position? That would be 1/2 AT squared. That would be 1/2 of 3 times 2 squared, which is equal to 6 meters. Oh, it's the same. Did I do that right? 3 times 4? That's just a fluke that it's the same. Okay, just one question like that, but let's get them all right. Right? That's what we want to do, get them all right. Don't want to miss one. Okay, other questions, particular questions? Yeah. Okay. Yeah, so it looks like we've done this one back, probably preparing for the quiz. Um, so I have an x component of a vector. I'm asking what is the x component, and the y component is 4. So this, just draw this triangle. So this is my y component. It's 4. And I know SOHCAHTOA, the tangent of an angle is equal to opposite over adjacent. That is that it's equal to the y component divided by the x component. And so I would say tan of 40 is 4 over x. I can solve this right here for x. X then is equal to 4 divided by tan 40. However you want to do that. You can cross multiply. You could, how would you do that? Multiply both sides by x and then divide both sides by tan 40. How did you do it?
I knew that like the angle was 40 degrees, so I just did it because there's and then pulled on top of like 40 degrees.
Okay. Have you put in these answers? Yeah, that's the more common. I mean, that was 4 steps that you had to do, right? So that's not wrong. That was okay, but it's a little more complicated. Is this clear? Yeah. Pretty sure you have some that are just simple. What's the x component? What's the y component stuff? Pretty sure that's the case. It's about half. Actually, I think there are 11 from chapter 3 and 9 from chapter 4, something like that. Slightly heavier towards chapter 3 in the multiple choice. And then there are 4, I think, for the, well, it's just like the fall 22. So I think that was 4 on the inclined plane and 4 on the chapter 3 stuff, vectors and projectile motion. I think that's right. Are there particular questions? Yeah. Okay. See several of these. So, which of these statements is true? If an object is moving across a frictionless surface with constant velocity. So, no friction. A is equal to 0 if it has constant velocity. The object has inertia. Yeah, every object that has mass has inertia, so that is true. The object has a net force of 0. If it has a net force of 0, that means that the acceleration is 0 because it's moving with a constant velocity. Yeah, that's true. So we know that 1 and 2 are correct, so that can't be right, that can't be right, and that can't be right. So the object will eventually stop. No, not unless another force acts on it. So no, we can't say for certainty that's true. Like this object could continue on forever until it reaches the edge of the universe, which is expanding at a rate faster than it's traveling. So it's going to just go on forever. And the object is accelerating. Well, no, because it's moving at constant velocity, then it's not accelerating, so it must be A. All right. Good exercise in these. Like I said, as you go through each statement, ask yourself, is it true? And then look at the options, just like I do, and begin to remove those that are not obviously true, or that are not allowed. A person is accelerating upward. Accelerating upward. the person feels lighter. True or not true? False, right. Not true. In fact, the person feels heavier. Remember that as we're looking at this, that my normal force and my weight are opposed to one another. So the sum of the forces is equal to the normal force minus the weight, and that's equal to the mass times the acceleration. So the normal force is equal to the force weight plus ma. And so if ma is positive, that means the normal force is bigger than the weight. The normal force is how much you feel, like the weight that you feel. It's actually what the scale reports for you. So you feel heavier. That's why it feels like you're just pulling down. The normal force on the person is larger than their weight. What do y'all think? Yes, that's just a restating of what I just said. That if this is positive, that means that this is bigger than that. If it's going down, that means this is negative, which means this is smaller than that. Right, I'm subtracting this from the weight to get the normal force, then it's smaller. So the normal force is larger, not smaller. So 2 and 3. All right, William, is that good? I know these are difficult. They do require a lot of different thoughts to come in your head. Just when you come to it, just take a big deep breath and just go one by one, okay? They're good for that reason because they require a lot of thinking. All right, other questions? Okay, no, remember I told, this is like one of those that was in the concept test that I said, oh, y'all won't see one of those. No, y'all can do it, I think, but we didn't talk about it in class. I'm not going to require that. That's number 13. Definitely not one of those on the exam or anyone similar that you might see. If you have any questions about that over the weekend, you just want to know, just shoot me an email. So no gravitation. So any of that G, MM over R squared stuff, not going to see that. Anything about the field force, the gravitational field force, not going to see that, not going to see this. Okay, is that okay, Ashton? Awesome. Yeah, happy. Okay, good. I'm glad you asked this. There was a similar question to this on the other one. Don't remember if this is on your exam, but it's one that I like. So make sure we have all of our forces drawn on here. Have Ft right here. We have a weight, Fw, Fw. Also have a normal force, Fn, and then there's a frictional force that is a static frictional force. So all that's described in here. It has a static frictional force. Obviously, it has a normal force and a weight. And then that Ft is already labeled there. Let's redraw this for the coordinate system just so it looks a little more approachable. Fn, F, and Fw. By the way, F is, well, we don't know what F is. We want to know. Fw is equal to 20. And Fs is in this direction. And Ft is equal to 20 newtons. Sorry, Ft equals 20. So that's our first step. We really don't know how we're going to proceed from here, but just even if you don't know, just go ahead and draw your vectors, make sure that they're drawn correctly. So I want to know what this force is because, the harder you push down on this, it's going to increase which of the other forces. It'll increase the normal force, which in turn will increase the frictional force. So we talked about this in class, where if I have an object and I push it along, you have a frictional force, but then if I push down on the object, then that frictional force is greatly increased. That the frictional force is dependent upon the normal force. So a couple things I know. First of all, I know that Fs is equal to 20 newtons. You'll see how I got that? Because I know that the sum of the forces in the x direction is equal to 0. This thing is not moving. We don't want it to move. And so Fs and Ft have to be equal and opposite. So Fs has to be 20 newtons. And further, that Fs is equal to mu times the normal force. That's 20 newtons is equal to 0.1 times the normal force. That means that that normal force better be 20 divided by 0.1, or 200 newtons. Okay? Can you see now where we're going to get the answer? You see the next step? What's the next step am I going to do? Now that I know the normal force and I want to know F, that force is pushing down, which forces will I consider? The forces in the y direction, because you see the normal force is dependent upon F and Fw. Some of the forces in the y direction, Fn minus F minus Fw equals to 0. So if I'm looking for F, F is equal to Fw minus Fn minus Fw. Excuse me. Which is, I've already found Fn, that's 200 minus Fw, which is 20. So it has to be 180 newtons. I need to push down with 180 newtons to keep that thing from sliding. There are variations of that problem throughout. Another variation is when the object is on a vertical wall. You might have seen that too, William. That's right, because that was the whole premise of the problem, that you want to keep the block from not moving. So if I push on this, it makes it move. What force is required to push down so that it doesn't move? Like I said, variations of that problem throughout. I don't know if it's on your exam. I don't remember, honestly, but probably there's some variation of it. So the other variation that you'll see is where I have an object on a vertical wall. So sort of the same problem. What force is required to keep it from sliding down? Very similar problem. I forget who asked that, but that's a good question. All right. Others? Yeah. What 22 and fall 20? All right. Fall 20, 22, and 23. Did I tell y'all that I was going to drop the lowest quiz grade? Oh, I did tell you in the email. Okay, good. Sure. This one right here? You know what the answer is for 22? I got it right here. C. All right, so this answer was 20 newtons. You sure you got that? Is it the same? It's a very similar problem. You want me to work through this one? It's similar but different. Y'all want me to do this one? Y'all, I hear, okay, another 5 minutes. Y'all aren't doing anything tonight, right? No. Oh. We're going to the football game at Toledo High. They're probably going to lose. That's okay. They're playing Hahnville High. Right, Hahnville's pretty good? Yeah, that's what I thought. All right. But my daughter, she's like the best marcher in the whole band. She is. And she's the best. She sounds the best too. Clarinet, which is one of my favorite instruments. So when I think I've told you this, when I was in band, it's like boys didn't play clarinet for some reason, which didn't make sense to me back then. I really wanted to play saxophone, but we couldn't afford a saxophone. It was like the most expensive instrument, and boys didn't play the clarinet, so I wound up playing the trombone, which was fun. I like playing the trombone. And then later I'd play the tuba. But, so it's like I get to live vicariously through her. Anyway, so I have the tension there, I have the weight here, and I have a normal force here. And then there is a kinetic friction, so it's Fk in that direction. Just like we did before, let's redraw this. so that the vectors Ft right there, that's what I'm looking for, Fn. I have 80 newtons, that's what I'm pushing down on it with, and 20 newtons, that's the weight, 20 newtons. So I can go ahead and say, actually, by the way, that Fn is equal to 100 newtons. You see how I did that? I just said 80 plus 20 gives Fn. And then I also have Fk. Also, I know that the sum of the forces in the x direction is equal to Ft minus Fk, where it deviates from that previous problem because this now has an acceleration. So that's going to be Ft minus Fk is equal to the mass times Ax. Now, I can also find Fk. Is this equal to mu, which is 0.1, times Fn, which is 100. So that's equal to 10 newtons. So I have some values here. Ft minus 10 equals to the mass, which is 2, times Ax, which is 5, positive 5. So Ft equals 20. That's where we get the 20 newtons required to accelerate it at 5 meters per second squared. Okay? Notice that if there was no friction, it would accelerate at 10 meters per second squared. But there is friction that slows it down. So let's go to the next one. What is the force due to gravity acting on the block? Oh, okay. Well, it's the force due to gravity is just the weight. It's 2 kilograms, so it's 20 newtons. Okay, what is the weight of the object? Alrighty. Other questions? All right. Let's stop. I'm going to pause here.